I, Richard Feynman, ask myself a strange question, a question that gets stranger the more I think about it. If I didn't exist, would the universe exist? That sounds absurd, egotistical. Of course, the universe exists independently of me. It was here billions of years before I was born. It'll be here long after I die. But quantum mechanics tells us something disturbing, something that challenges this obvious truth. My teacher, Non Wheeler, brilliant physicist, one of the great minds I've known, he told me something years ago that I couldn't shake. We were at Princeton. I was young, working on my PhD. He was already famous, already thinking about black holes, about quantum gravity, about the deep questions. Richard, he said one day after a seminar where we'd been arguing about measurement, the universe is participatory, not just observed. Participated in the observer isn't separate from what's observed. The observer is necessary for reality to become definite. I laughed. I thought he was being philosophical, playing with words. Wheeler did that sometimes. He loved language, loved metaphor, it from bit. He'd say information gives rise to reality, but he was serious, dead serious. And over the years, as I worked more with quantum mechanics, as I calculated more path integrals, as I thought more deeply about measurement, I realized he might be right. And here's what really struck me, what kept me up at night thinking about it. Measurement in quantum mechanics doesn't just reveal what's there, it makes what's there definite. Before measurement, the system is in superposition, multiple possibilities. Not one thing that we don't know, actually multiple things simultaneously. The observer, the measurement collapses. The wave function makes one possibility actual, makes reality definite. Without an observer, quantum mechanics says the system stays in superposition, indefinite, undefined, not real in the usual sense. Wheeler took this further. He proposed the participatory universe, the idea that the universe needs observers to become real. That observation isn't passive witnessing, but active participation in creating reality. And then Wheeler proposed an experiment that seemed impossible when he first described it, an experiment that seemed to violate causality, violate everything we think we know about time and cause and effect. The delayed choice experiment. When he first told me about it, I thought, this can't work. This violates causality. You can't affect the past. That's absurd. But Wheeler smiled. He said, Richard, quantum mechanics doesn't care about what seems absurd to us. It cares about what the mathematics says, and the mathematics says this should work. And it does work. We've done it multiple times with photons, with atoms, with increasingly sophisticated setups, and every time we get the same disturbing result. What you choose to measure now determines what happened in the past. Let me explain the experiment carefully, because this is where it gets really strange. Where quantum mechanics shows us that reality is far weirder than we imagine. The delayed choice experiment is a variation of the double slit experiment. You know that one? It's the classic. The one that shows the weirdness of quantum mechanics most clearly. A photon, a single particle of light, approaches two slits. If you don't measure which slit it goes through, it creates an interference pattern on the detector screen. Light and dark bands. The pattern you get when waves pass through both slits and interfere with each other. The photon went through both slits simultaneously like a wave interfered with itself, created the pattern. And this is the key, if you put detectors at the slits to measure which one the photon went through, the interference pattern disappears. You just get two bands like particles going through one slit or the other, no interference. The photon went through one slit like a particle, didn't interfere with itself. The measurement changes the behavior, fundamentally changes it, not because the detector disturbs the photon, though it does, but because the measurement collapses. The wave function makes the superposition both slits into a definite state, one slit. That's quantum mechanics. That's the observer effect. That's what made Bohr and Einstein argue for decades. But here's Wheeler's brilliant, disturbing twist, the thing that seems impossible. What if you decide whether to measure which slit after the photon has already passed through the slits, after it's already done whatever it's going to do? Set it up like this. Photon approaches the slits, goes through, then travels to the detector screen. But before it hits the screen, you can choose right then at the last second whether to measure which path it took or whether to let it hit the screen and see if there's interference. You choose after the photon passed through the slits, after the decision of wave or particle should have already been made. Classically, this is nonsense. The photon already went through. It already behaved as wave or particle. Your later choice can't change what already happened. The past is fixed. But quantum mechanically, Wheeler said, your present choice determines the past behavior. Choose to measure which slit, particle behavior, one slit, no interference. Choose not to measure wave behavior. Both slits, interference pattern. Your choice now made after the photon passed through determines whether it went through one slit or both slits, determines its past behavior. This seemed crazy, too crazy. It violates our intuition about time, about causality, about how reality works. If you decide to measure which slit even after the photon passed through, you get particle behavior. No interference like it went through one slit. If you decide not to measure, you get wave behavior. Interference like it went through both slits. Your choice now determines what the photon did then. Your present measurement affects the past behavior, not metaphorically. Actually, the experiments have been done. The results are clear. We've done this with photons that traveled for billions of years before we measured them. Light from distant galaxies, quasars billions of light years away. Think about what this means. Really think about it. A photon leaves a quasar 8 billion years ago. Long before Earth existed, long before the sun existed, long before any life in the universe that we know of. That photon travels through space for 8 billion years, through expanding space, past countless galaxies, through the cosmic void. Finally, in 2024, it reaches Earth. It enters our telescope, and we choose right then how to measure it. Wave or particle, which path? And our choice now, today, determines whether that photon behaved as a wave or a particle 8 billion years ago when it left the quasar. Our present measurement affects the ancient past across billions of years, across cosmic distances. This isn't theory. This isn't speculation. This has been done. The experiments have been carried out with light from distant quasars. The results are exactly what quantum mechanics predicts. The photon's past behavior is indefinite until we observe it, until we make a measurement, until consciousness, or at least the measuring apparatus, participates in defining what happened. Wheeler saw this and said, the universe's past is not fixed, not at the quantum level. The past becomes definite only when it's observed, when the present makes a measurement. And if that's true, then observation is not passive, it's creative. It participates in making the past real. Wheeler called this delayed choice. The universe's past isn't fixed until we observe it, until we make a measurement, until consciousness participates. This disturbs me deeply because it suggests that observation consciousness plays a fundamental role in reality, that the universe isn't complete without observers. Let me be clear about what this doesn't mean. It doesn't mean you can change the past arbitrarily. You can't go back and prevent Kennedy's assassination by measuring something now. The delayed choice affects the quantum state, not macroscopic events, but it does mean that quantum reality, the fundamental level, isn't definite until observed. The past at the quantum level is indefinite until the present observation makes it definite. And if that's true for photons, what about everything else? Everything is quantum at the fundamental level. Atoms, molecules, matter, energy, all quantum systems. Does that mean the entire universe was indefinite until observers evolved, until consciousness arose? Wheeler thought so. He proposed that the universe created conditions for life, for consciousness, so that consciousness could look back and make the universe real. The universe needs observers to exist, and it creates the conditions for observers to arise. A self-consistent loop, the participatory universe. Now, I don't know if this is true. Wheeler was brilliant, but he was also speculative. He loved big ideas. He pushed boundaries, but the delayed choice experiments are real. The results are real. The mathematics is clear. Observation affects the past quantum state. So I ask myself, what does this mean for me, for consciousness, for death? If observation is necessary for quantum reality to become definite, then consciousness isn't just a witness to the universe. It's a participant. It's part of what makes the universe real. My consciousness, my observations over my lifetime, they've been collapsing wave functions, making quantum states definite, participating in creating reality, not in some mystical sense, in a precise quantum mechanical sense. Every time I observe something, I collapse a wave function. I make one possibility actual. I participate in defining reality. And not just me. Every conscious being, every observer, all participating, all making reality definite. Does this mean consciousness is fundamental? Is consciousness required for the universe to exist? I don't know. The measurement problem in quantum mechanics is unsolved. We don't know what counts as an observer. We don't know if consciousness is necessary or if any interaction counts as measurement. But the delayed choice experiments show that observation has a special role, that it affects the past, that it makes quantum states definite. And if consciousness is the observer, then consciousness participates in creating reality, in making the universe real. What happens when I die? When my consciousness stops observing, this is the question that haunts me now, that I think about more than I used to. The usual view, the standard materialist view, says nothing special happens. I'm one observer among billions of humans, billions of animals, countless measuring devices. The universe continues without me. Other observers keep observing. Reality continues being definite. My death is local, personal, sad for those who know me, but cosmically insignificant. The universe doesn't care, doesn't notice. But Wheeler's participatory universe suggests something different, something stranger, something that I'm not sure I believe, but can't quite dismiss. If consciousness is necessary for reality to be definite, if observation makes quantum states collapse, makes possibilities become actual, then my consciousness is part of the universal observer, part of the cosmic measurement apparatus, part of what makes reality real. I've spent 70-some years observing the universe, collapsing wave functions, making quantum states definite, participating in creating reality. Every time I looked at the stars, I participated in defining how the photons traveled, whether they were waves or particles, what paths they took through space. Every time I did an experiment, I collapsed wave functions, made quantum states definite, participated in defining what was real. Every conscious moment, every observation, every measurement, every act of attention, participating, making the universe definite, making it real. When I die, that stops. My part of the universal observation ends. My participation in creating reality ceases. Does that matter? Does. Does the universe become slightly less definite? Does some part of quantum reality return to superposition because I'm no longer observing it? Or, and this is the stranger possibility, the one I hesitate to even voice, does consciousness not actually end? Does it continue in some form as part of the universal quantum state? Still observing, still participating? I don't know. I really don't. These questions go beyond physics, beyond what experiments can answer, at least for now. But the delayed choice experiments show that observation is special, that it has power over the past, that it makes reality definite in ways we don't fully understand. But the delayed choice experiments show that observation affects reality in ways we don't fully understand, that the past isn't fixed until the present observes it, that consciousness, or at least measurement, plays a fundamental role, and that changes how I think about existence, about my role in the universe, about death. I'm not just a witness to reality, I'm a participant. My observations make quantum states definite. My consciousness contributes to making the universe real. When I look at a star, I don't just see light that left the star years ago. I participate in defining how that light traveled, whether it was wave or particle, what path it took. My observation now affects the photon's past, makes it definite, makes it real. This is participatory. This is Wheeler's vision. The universe and consciousness co-creating reality. Is it true? I don't know, but the experiments support it. The mathematics requires it. And it's beautiful and strange and unsettling. I, Richard Feynman, exist. And by existing, by observing, I participate in making the universe real. This is what Wheeler taught me. This is what the delayed choice experiments confirm. I'm not just a witness to reality. I'm a participant in its creation. My observations matter, not in some vague metaphorical sense, in a precise quantum mechanical sense. When I look at the night sky, I'm not just seeing light that left stars millions of years ago. I'm participating in defining how that light traveled, whether it was wave or particle, what path it took through the cosmos. My observation now affects the photon's past, makes it definite, makes it real. This is profound. This changes what it means to be conscious, to be an observer, to exist. I am not separate from the universe. I am part of how it becomes definite, how it transitions from quantum superposition to classical reality. Every conscious being plays this role. Every observer, every measurement, all participating, all making reality real. And when I die, maybe I stop participating. Maybe my wave function collapses one last time. Maybe the universe continues without my part of the observation. Other observers taking over, reality staying definite. Or maybe Sadi and I say this with all the uncertainty it deserves. Maybe consciousness is more fundamental than we know. Maybe it's not just an emergent property of complex brains. Maybe it's woven into the quantum state itself. Maybe observation consciousness is a fundamental feature of reality, not a derived one. Maybe when I die, the pattern dissolves, but something persists. Some aspect of the observing, the participating, continues in a form we don't understand yet. I don't know. I can't know. These are speculations. Wheeler's participatory universe is itself somewhat speculative. The delayed choice experiments are real, but their interpretation is open. But I know this. The universe is stranger than we thought. Observation is more powerful than we imagined. Consciousness plays a role we don't fully understand. We are not passive witnesses to a pre-existing reality. We are active participants in making reality definite, in collapsing quantum superpositions into classical facts. The participatory universe, Wheeler's vision supported by experiments consistent with quantum mechanics, disturbing, beautiful, strange. I, Richard Feynman, have participated in this universe for 70-some years. And it has been an honor, a privilege, a wonder to observe, to measure, to participate in making the cosmos real. That's what consciousness does. That's what we do every day, every moment. We don't just witness the universe, we help create it. And maybe in some way we don't yet understand that participation continues beyond death, beyond the dissolution of the pattern. Maybe the observation never truly ends. Maybe we are always part of the universal quantum state, always participating, always making reality real. I don't know, but I find the possibility beautiful. The participatory universe, where consciousness and cosmos create each other, where observation makes reality, where we are not separate from what we observe. That's what quantum mechanics suggests. That's what Wheeler taught me. That's what the delayed choice experiments show. We are the universe observing itself, participating in its own creation, making itself real through consciousness. And that is strange and wonderful and terrifying and beautiful all at once. The observer creates the observed. The universe creates the observer, a self-consistent loop, a participatory dance. And I, Richard Feynman, have been honored to participate for now, and maybe in ways I don't understand, forever.